Okay, 2.2 homework help. So this, we're going to be completing the square. So the first thing I want to do here is figure out what value helps me complete this square. Well, remember, to complete the square, we're always just going to look at this middle value right here. Okay, so we have 32. And I'm going to take that 32 and I'm going to divide it by 2. And I end up getting 16. Okay. And then that's not what I put right here. What I'm going to end up putting right there is I'm going to take the 16 and I am going to square it, which 16 squared ends up being 256. So the value that goes right here is 256. And then we want to rewrite this as a perfect square. Well, to do this, we're trying to see what multiplies to be 256, adds to be 32. It will always be whatever this number was. So it's going to be 16 and 16. Because 16 times 16 is 256. 16 plus 16 is 32. So then this is going to be n plus 16, n plus 16, which is going to equal n plus 16 squared. Cool. This one, so again, we're going to take this middle number, 21. We're going to divide it by 2. And you get 10.5. Okay, or you could just leave it as 22nd halves. But then we're going to square that. Which we get 110.25. And I don't care if you leave this as a decimal or if you write it as a fraction. Because say we left it as a fraction, which probably is a little bit better to do. So we could take this, 21 halves, and square it. So if I square this and I leave it as a fraction, I get 441 over 4, which is what the answer is probably going to say. So then this would be z squared plus 21z plus 441 over 4. Okay, again, I don't care which way you do this. This one's probably a little bit more better. That's really good grammar. Okay, but then for my perfect square, it's always this value here. So we could write this as z plus 21 halves squared, or we could do z plus 10.5 squared. Okay. Okay, let's go to the next one. So these ones are just factoring these completely. You know how to do this. Whoops. This one we've done before. Or we were doing these last time, but okay, so we're seeing what multiplies to be 25, adds to be 10, it's 5 and 5, so then this will be n plus 5, n plus 5, which is going to be n plus 5 squared. Okay, I do want to go over how to factor this, so we're going to multiply the 9 to the 25, and you get 225. So we want to see what multiplies to be 225 and adds to be negative 30. Well, let's just go through the factors. So we have 225 and 1, which that's not going to help us. We have 2 doesn't go into it. 3 goes into it 75 times. Oh, whoops, I'm doing this backwards. Let's do 1, 2, 25. 3 and 75. 4 doesn't go into it. 5 goes into it 45 times. I don't think 6 goes into it. What about 7? 8? Nope. 9. 9 and 25. 10 doesn't go into it. 11 doesn't go into it. 12 definitely doesn't. 13, and I'm literally just checking all these. You might hear myself typing on this calculator. 14 doesn't. 15 does 15 times. Sweet. So that means if we need it to be a negative 30, these both need to be negative. And I'm just going to do this by grouping. So I have 9x squared. These are going to replace this right here. So this will be minus 15x plus 25. Group these ones, group those ones. Between these two, I can take out a 3x. Between these ones, I could take out a negative 5. So then I have 3x, and then 3x minus 5. And then same thing here, 3x minus 5. So this is one of our factors, 3x minus 5. This is our other, 3x minus 5. So this will be 3x minus 5 squared. Cool? Okay, let's go to this next one. So here we're graphing this. And if we think about our normal parabola, so just like our normal x squared, and say that this is our x, this is our y. And I went 0, negative 1, negative 2, negative 3, 2, 1, 2, 3. So if I plugged in 0 to here, so 0 squared, say this was y equals, I would still get 0. So that means this y is 0. If I plug in 1, I would just get 1. Same thing with negative 1. 2 squared, that would equal 4. So this is 4, and this is 4. I'm just making a table here. Okay, because same thing if I plugged in negative 2, I'd get 4. And if I plugged in 3, I'd get 9. Or negative 3, I'd get 9. Okay, this is important right here. I'm going to erase this part of it. But this little table here is going to be important to us. Okay, now let's look over here. This is vertex form. So this tells us what the vertex is. So it's the opposite of this one and this one. So this is going to be, if I set that x plus 1 equal to 0, I'd get x equals negative 1. So the x value is negative 1, and the y value is just what's ever on the outside. So I'd go negative 1, 1, and that's where that point is. Okay, but now this 3 on the outside here means that I'm going to multiply all of these y values by 3. Okay, so that's going to be 27, 12, 3, 0, 3, 12, 27. So typically I would go over 1 to the left and up 1, but this time I'm going to go over 1 to the left and up 3. 1, 2, 3. Same thing here, over 1, up 1, 2, 3. Then I'm going to go over 2, up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And same thing this way. So there would be my parabola for that one. Okay. This hopefully is kind of review. You should have graphed these last year, but who knows? Okay, let's do ones where we have to complete the square to get it into that form. So let's complete the square for this one. So if we have negative x squared plus 6x minus 6, I want to just look at these two, and I'm going to move this over. I'm not going to deal with that right now. So we can write this as negative x squared plus 6x plus something is going to or not equal, and then the minus 6 is still on the outside. Now here, I don't ever want anything in front of this, so I'm going to factor out a negative 1 here. So this is going to be negative 1, and then x squared minus 6x plus something is going to equal negative 6. Not equal. Why do I keep doing that? Minus 6. So to figure out this number, it's kind of like what we were doing at the beginning. So we're going to take this negative 6, We're going to divide by 2, and we get negative 3. Then we're going to square the negative 3, and you get 9. So we're going to add 9 here. But if we're going to add 9 here, I need to add something on the outside too. So typically, if there was this 1 right here was not here. So say that this wasn't here, then I could just go minus 9. Okay, but since that 1 is here, I'm going to multiply this in. Negative 1 times 9 is negative 9. So this is really the same as subtracting 9. So I'm going to plus 9 on the outside here. Okay, hopefully that kind of makes sense. So then if I was to simplify this further, I'll do it in black now. So this will be negative 1. And then this, remember we can write it as a perfect square with whatever that number is. So this will be x minus 3 squared. And then negative 6 plus 9 is going to be plus 3. Now that is something that we can graph. So our vertex here is going to be at the opposite of that. So positive 3, 3. So if I go over 3 and up 3, there's that vertex right there. And then typically, remember our table, if we had x, y, so it would be negative 3, 9, negative 2, 4, negative 1, 2, 0, or not 2, sorry, negative 1, 1, 0, 0, 1, 1, 2, 4, 3, 9. But we have this negative here on the outside. So I'm just going to multiply all of these values by negative 1. So that means instead of going over 1 up, I'm going to go down the 1 and down the 9, or down the 1, 4, 9. So from this point, I usually go over 1, up 1, but now I'm going to go over 1, down 1, over 1, down 1, over 2, down 1, 2, 3, 4, over 2, down 4. Okay. All right, let's do this last one. So I'm going to rewrite this. Let's do it in purple, I guess. So this is going to be 2x squared plus 16x plus some number, and I'm going to put this in parentheses, plus the 29 on the outside. But I don't want this 2 in here. I want it to just be an x, so I'm going to divide that 2 out. So that's going to be 2. And then in the parentheses, I'm left with x squared plus 16 plus 8x plus some number, and then plus 29. To figure out what that number is, I'm going to take 8 divided by 2, and you get 4. And if I do 4 squared, I get 16. So this is going to be a 16 right here. But if I add 16 there, I have to like undo that addition, or I'm changing the whole problem, and I can't change the whole problem. So I need to figure out what to add or subtract on the outside. So since we have that 2 here, I'm going to do 2 times 16 is 32. So that's really the same as adding 32 in there, which means to undo that, I'm going to subtract 32 on the outside. Okay. So then this is just going to be 2. To make this a perfect square, I'm just going to look at that 4. That's going to be x plus 4 squared. 29 minus 32 is negative 3. Okay, so our vertex here is negative 4, negative 3. So let's draw that negative 4, negative 3. And then if we look at that same table, I'll just rewrite the table here. So we have x, y, negative 3, 9, negative 2, 4, negative 1, 1, 0, 0, 1, 1, 2, 4, 3, 9. But now we have this 2 on the outside here. So that means I'm going to multiply all of these by 2. So this would be 18, 8, 2, 0, 2, 8, 18. So I'm going to go over 1 up 2, over 1 up 2, because we think about this as like our 0, 0. And then we'd go over 2 up 8, 1, 2, 3, 4, 5, 6, 7, 8. And then 2, 1, 2, 3, 4, 5, 6, 7, 8. So then here would be our parabola. Whoops. Okay. Sorry this was a little bit longer, but these are some homework problems, so I just did some of those homework problems for you. But anyways, hope this helps. Bye.